All right, so in these next couple of examples, we're again going to be looking at this idea of we're going to be given some statement written out in English, and it's going to be our goal to first write this thing down in symbolic form, in this case, bringing into place some of these quantifiers. Then we're going to use this information that we know how to negate these giant big expressions. Kind of once we have it in symbolic form, then negation becomes really easy. And then once we actually write that negation in symbolic form, we're going to double back and actually try to write that thing as a nice English statement. In this case, not just putting the word "it is not the case," because that's the really kind of boring version to negate something. Yes, it is officially a negation, but it's not an overly useful negation. So in this case, we're going to be looking at a bunch of different types of statements. Some of these you're going to see are going to have the universal quantifier coming into play. Others are going to have this existential quantifier. Others are going to have some built-in negations as part of the actual statement. You can see some no's floating into play. All of those little tiny things become little subtleties that you want to just become really comfortable with, kind of manipulating those things as you go. So in this case, it's a bunch of just really somewhat hokey statements, the first of which is going to say some old dogs can learn new tricks. So it kind of goes off this old saying that old dogs can't learn new tricks. And you're going to see that when we actually talk about the negation of that thing. But for right now, it's just going to be this statement that says some, which hopefully is sounding the alarm of this existential. There's going to be at least one old dog, and what does that old dog have the ability to do? That old dog can learn new tricks. And that's exactly how we're going to set this thing up. I'm going to have my giant big universal set. In this case, that big set is going to be all of these old dogs. And I'm free to call that thing whatever I want to. As always, it helps to use somewhat suggestive notation. So in this case, the set D is going to be the set of old dogs. And then I'm also going to introduce this predicate, this idea of what can these old dogs actually do. And in this case, my kind of world that I'm going to be living in is all talking about this idea to learn new tricks. So in this case, I'm going to have my predicate, which I'm going to use T for trick. It's going to eat in different types of dogs, and it's going to indicate whether or not that dog can learn a new trick. So in this case, it's going to say X can learn new tricks. Okay, so in this case, I have my two things set up. In this world, I actually had the freedom to choose whatever I wanted to. Other times, we're actually going to identify, I want the universal set to be blank, and I want the predicates to be blank. And in that case, you have to see how all those things interact a little bit. But in this case, we're free to choose whatever world we want to. In this case, I'm identifying the world of all old dogs to be my universal set. And then within that, I'm going to have this ability to talk about whether or not that those particular dogs can actually learn new tricks. Okay, so what does this statement actually look like in symbols? I'm going to have some, which I mentioned is this existential quantifier. That is, there's going to exist, in this case, what happens is there's going to exist at least one dog. We're going to call that dog X. You could say Fido or whatever type of dog you wanted to in this case. There exists some dog in the set of all dogs, or in this case, old dogs. And what does that dog have the ability to do? That dog has the ability to learn new tricks. And that's it. All it says is there exists an X in the set of D such that T of X occurs. And T of X is the fact that X can learn new tricks. And that's it. That's all that statement is. It's a pretty simple existential statement. What I want to do is I really want to talk about the negation of this thing, bringing into this kind of ability from we just saw in that last theorem, this idea that if I negate one of these existential operators, what's going to happen is I'm going to introduce this universal quantifier, this kind of flip-flop between these things. Going from existential to universal is also going to pick up a negation of that predicate as well. So in this case, looking at this giant negation, I'm going to have this negation of my statement, which says there exists an X in D, and then I'm going to have my predicate, which just says T of X. Using that theorem that we just saw, what this is going to say is it's going to say a universal quantifier, in this case for all X and D, and then I'm going to pick up the negation of my predicate T of X. And that's it. Like I said, it's pretty nice once you actually have this thing in symbolic form. You can convert this thing from the initial statement to its negation. All you got to do is just bring this kind of negation kind of operator across. You're going to change that existential into a universal, and these kind of initial predicates are going to pick up negations. What that's going to read then, if you put that back into English, is going to say for all dogs in the set or for all dogs or for all X and D. The idea is that every single possible dog is going to have this ability. And what's that ability? It's going to have the ability to not learn new tricks. So you're going to say that all old dogs cannot learn new tricks. And however you feel like changing that thing up, you have the ability to kind of manipulate that thing. You might just say that old dogs cannot learn new tricks. In that case, it's kind of embedding this for all or this all expression into the actual statement saying old dogs in general cannot learn new tricks. So I have my initial statement, and then I'm going to have my negation. So you can see I went from an existential or this sum into a statement about for every. Okay, let's look at another one. I'm actually going to jump up to C in this case, and then we're going to come back to B, and I'm going to let you look at D and E on your own. In this case, we're going to look at this expression that's going to say every bird can fly. Hopefully when you look at that, you're seeing this giant every jumping off the screen, saying, hey, this is going to be some universal quantifier. In this case, what am I going to be talking about? I'm going to be talking about birds. And what do these birds have the ability to do? It's the idea that they can fly. So in this case, what I want to do is I want to introduce what is my giant universal set going to be. In this case, I'm just going to identify my set to be the set of all birds. So in this case, I'm going to use B for birds. My predicate in this case is going to be the idea that this particular object X can fly. So in this case, my overall statement is going to simply say, for all x's, so for every bird out of that collection of birds, what do those birds have the ability of doing? They have the ability to fly. And that's it. So if I wanted to, I can go ahead and negate this thing. It's a pretty simple negation as well. I'm going to have a negation of that giant thing out in front, and then it's going to have this operator of flying. All right, so applying that theorem, what's going to happen is that this negation operator is going to attack this universal quantifier. It's going to turn it into an existential quantifier. And then what's going to happen is that I'm also going to pick up a negation on my predicate. So what this is going to say is there exists some bird in the collection of all birds that has the property that cannot fly. That is, there exists a bird that cannot fly. In this case, this is actually true. There's plenty of birds that actually have this ability that they cannot fly. For example, an emu or something like that. These giant, large, kind of running around birds that actually have tiny little wings don't have the ability of flying. So in this case, my original statement that says every bird can fly is actually false. And the reason for that is because there exists some bird that cannot fly. So there's this nice kind of connection between the original statement and the negation of these two things. I know that this one is true, which tells me that my original statement must be false. Okay, so let's go back to part B, which has a little bit of weirdness going on in this case. There has a negation in this thing already. It's the idea that it has the word no already incorporated into this expression. It says, no rabbit knows calculus. So there's a couple different ways you can actually go ahead and attack this thing, both of which are actually going to revolve around the world that I'm going to have to identify my entire world. In this case, my world is just going to be the collection of rabbits. So let's go ahead and do that. So R is going to be the collection of rabbits, and what do these rabbits have the ability of doing? They're going to have some information about whether or not they know calculus. So C of X is going to be that X knows calculus. Okay, so like I said, here's the idea of how we can kind of change these things up. Where we choose to incorporate the negation is a little bit up to us in this case. What I could do on one side is I could say, kind of leaving that no until the very end. So the idea is that there's going to exist some rabbit who knows calculus, and then I'm going to negate that overall thing. What that would say is there exists a rabbit, and what does this rabbit have the ability to know? It has the knowledge of calculus. And I'm going to put a negation in front of that, saying that that is actually where that no is coming into play. That's actually kind of awkward for me to think about. I don't like sometimes thinking about it like that. The way when I read that is I'm going to have a statement that's going to say every possible rabbit has the ability that they do not know calculus. And that's the way that I personally like to think about these things. I like always introducing this idea of these universal quantifiers. It's this idea that I'm going to cycle through all of these possible rabbits, and then I'm going to do a check on them. Does this rabbit happen to know calculus, yes or no? That's just the way that I'm kind of programmed in this case. Is like to think about these giant loops. I'm going to loop through all of the possible rabbits and then test whether or not they know calculus or not. But what's nice about this is you can actually see that those two expressions, the one that I wrote down first and the one I wrote down second, are in fact equivalent. If you look at it, all I'm doing is I'm bringing in this negation operator. That existential turns into a universal, and then that knowledge of calculus is actually going to become negated when I bring that negation operator on the inside as well. So it's kind of nice to see the two different ways you could think about writing down that negation actually end up being equivalent when I put them in symbolic form. So it helps, you can write it down in that first version, or you can write it down in the second one, both of which are actually valid negations. or valid versions of that statement. What I want to think about then is when I go back to the negation side of this thing, well, I can either negate the first one that I looked at, which is going to then have a double negation, which you can then see is going to become really easy when it comes to negating this thing, because what's going to happen is that immediately I'm going to apply the double negation. I have a negation, which is going to say there exists a rabbit in the collection of all rabbits, and that rabbit happens to know calculus. So there's a valid negation of that statement. Or what I could do is I could negate that second version of that statement and see the exact same thing occur as well. If I take the negation of that thing, I'm going to still at some point in time have a double negation occur. What's going to happen is that I'm going to have this negation of this universal quantifier, which is going to turn into an existential quantifier. And then here's where that negation operator is going to come into here, and I'm going to have a double negation occurring, which is going to say those are all just going to kill each other off. And you can see that I'm left at the exact same final point. That is, these things that I started with over there were actually exactly the same. So when it comes to actually negating these things, it should stay the exact same as well. So it's kind of nice to see all of these different paths you can possibly take all lead to the exact same conclusion. In this case, if I write this thing with this negation on the way outside, when I double negate it, that's all going to go away. Or if I bring the negation on the inside and then double negate it, in this case, I'm going to see all of those things kill each other off as well. And back to where I started as well.